Good evening, class. Today we're going to look at segment lengths and circles. This is the second to last real new thing we're doing in this section. We've looked at inscribed polygons, we've looked at angles inside of circles, we've looked at angles outside of circles, we've looked at arcs, we've looked at tangents, we've looked at chords. We've looked at a lot of angle measures. In fact, the last time we did anything with length, I think would have been all the way back with section 1 with radius and diameter. So we are going to do just a little bit with finding lengths of segments, and that's what section 6 is. Everything else is angle measurements. This one is length measurements. So the first thing we're going to look at are segments of chords. Now, a segment of a chord is part of a chord. Two segments of a chord make up a full chord. So if you look at the picture in the bottom left there, segment A and segment C would add together to be the chord. Segment B, segment D would add together to be a chord. So all four of those are segments of chords. And here's the thing. If two chords intersect on the inside of a circle, which that's what's happening right there, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So if I look there, what that's saying is if I take B and multiply it by D, it has to equal C times A. That's all it says. Alright, so let's try and use this in a few examples. Well, right here, find the value of x. So I look, in both pictures, I have two chords intersecting on the inside of my circle. So I'm going to use the rule I just learned, which is this rule right here. I'm going to take one part of the chord, times it by the other part of the chord. And I'm going to set that equal to the other two segments of chords multiplied together. So let's take a look. Alright, so if I use the rule I have, these two chords are intersecting each other. If I want to find their lengths, I can take this part of the chord, multiply by that part. 2 times 2x plus 3. And then I take 7 and x minus 3 and multiply them together. 7 times x minus 3. And those two should be equal. Look, I use the same segment, or the same chord, when I do a side of my equation. Same chord, same side of the equation, and I'm multiplying the two parts together. At this point, it's just algebra. Distribute both sides. So this becomes 4x plus 6. That becomes 7x minus 21. Subtract 4x from both sides. I get 6 equals 3x minus 21. Add 21 to both sides. 3x equals 27. And divide both sides by 3. X equals 9. Now I'm only looking for x, but I probably should make sure that I get numbers that make sense. If I put 9 in here, 9 minus 3 is 6. If I put 9 in here, 9 times 2 is 18, plus 3 is 21. 6 times 7 is 42. 2 times 21 is 42. It works. The next one might be a little bit more challenging, but we should still be able to do it. So take part of a chord, segment of a chord, 5, multiply by its other segment of a chord, x plus 3. Other side of the equation, take the other segment of a chord, x, and multiply by its other segment, x plus 7. At this point, I solve for x, so distribute 5x plus 15, because I distributed like this, and then x squared plus 7x. Alright, let's try and get all the x's to one side. 15 equals x squared plus 2x, because I subtracted 5x from both sides. There's no way to really get rid of this easily. So what I'm going to do is I'm going to move 15 over to the right by subtracting 15 from both sides. So I'm going to get 0 equals x squared plus 2x minus 15. At this point, I have two options. The first option is reverse FOIL, where I say 0 equals into parentheses, I figure it out. If I want to find out what x is from here, I could choose this route. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. Now, some of you know the song. I'm just very musically challenged, so I'm not going to butcher it. But anyway, that's what I could use. Where 0 equals ax squared plus bx plus c. So in this case, a would be 1 because 1's in front of x squared, b would be 2 because 2 is in front of x, and c would be negative 15. I just plug it in and find it. So x equals negative 2 plus or minus square root of 2 squared minus 4 times 1 times negative 15 all over 2 times 1. So x equals negative 2 plus or minus square root of 4 minus plus 60 all over 2. X equals negative 2 plus or minus the square root of 64 all over 2. So x equals negative 2 plus or minus 8 over 2. And then there's two different answers there. X equals negative 2 plus 8 over 2, which would be x equals 3. Or the other option would be x equals negative 2 minus 8 over 2, which means x would equal negative 5. If I try and plug a negative 5 back in, it doesn't work, so even though it was a solution, x equals 3. That's a lot of work. I honestly wouldn't do that unless I had to. I would honestly try this. Well, if I'm reverse foiling, x multiplies by itself. This here is a minus sign, so one of these is a minus, one of these is a plus. I need two numbers that multiply to be 15, subtract to be 2. Well, 3 times 5 is 15, and when I take the difference of 3 and 5, I get 2. Okay, so 3 and 5 is my choice. But now, 2 is positive, so the bigger number has to be positive. So 5 is positive, 3 is negative. So it's either x minus 3 equals 0, or it's x plus 5 equals 0. So I get the answer x equals negative 5, or x equals 3. And again, only x equals 3 works. So it's either choice. You can go here, quadratic formula, that should always work. Or you can do reverse FOIL, and you might have a shortcut. Alright, so these are the only examples I'm going to do for finding the segment length of a chord. There's other lengths we have to find, so we're going to look at those next. By the way, everything we deal with in this section will be segments. Because lines, I can't find the length of ever. Or rays, I can't find the length of ever. So we're only looking at segments. So we're only going to look at segments of secants. A secant segment is a segment that contains a chord of a circle and has only one endpoint outside of the circle. So if I look here, this segment right here is a secant segment because it is made up of a chord A, and it has only one endpoint right up here that is outside of the circle. So it is a secant segment. The external segment of a secant segment is the portion of the secant segment outside of the circle. So in this case, B here is the external segment, and C here is an external segment of my secant segment. Alright, ready for something wordy? Let's go. If two secant segments share the same endpoint outside a circle, so look at the diagram in the bottom right, that's what they're talking about. Then the product of the lengths of one secant segment and its external segment, that's this part right here, B times B plus A, equals, equal sign, the product of the lengths of the other secant segment and its external segment, which is C and C plus D, because that's the external part times the full length. The first part over here, B times B plus A, is the external part B times the full length, B plus A. And that's all this is. It's just a way for us to remember how to set it up. On each side of the equal sign, I will be dealing with only one segment at a time. So whenever I put something on one side of my equal sign, it's from one segment. Okay? I will not be mixing and matching my segments together in my equation. So, example 2, it says find the value of x. Basically, use the theorem I just said and show me how to use it. So in this case, let's redraw the pictures and then let's apply it. Alright, so in each of these cases, they're just asking me to find x. So let's use the rule. In both of these, I know I'm doing it equal. And I know I'm going to be doing a multiplication on each side, so I'm going to put a parenthesis. Now it's the external part. So for instance, 5 is an external part. Times the full length. Well, the full length here is 5 plus x. I choose again, but I choose the other secant segment. 7 is the external part. Times the full length. 7 plus 10, or 17. At this point, I just simplify until I can't go any further. Distribute over here, I get 25 plus 5x equals, multiplied there, 119. Yep, 119. Subtract 25 from both sides, 5x equals 94. Divide both sides by 5, x equals 18.8. And there we go. X is 18.8. Alright, let's do the geometry part. Let's set up over here. The setup. Right away, I'm looking for lengths in a circle. So I know I'm going to be setting something equal to something. I know because it's secants. Secant segment. I'm going to be multiplying the outside part by the full length. So the outside part here is 3. The full length is 3 plus x. Here, the outside part is x. The full length was x plus 11. And at this point, it's just solve for x. Algebra. Distribute. So this is x squared plus 11x. And this will equal 9 plus 3x. Get everything to one side like that last problem. So x squared plus 8x equals 9. And I'm going to get x squared plus 8x minus 9 equals 0. I'm going to do reverse FOIL, but if you want to do quadratic equation, go ahead. I'm just not going to use all that space. So I'm looking for two numbers. Well, look, x. The only way to get x is x times x. There's a minus sign here. So one of these is a minus, one of these is a plus. I need two numbers that multiply to be 9, but subtract to be 8. Well, let's see, 9 and 1. They multiply to be 9. 9 times 1 is 9. And they subtract to be 8. 9 minus 1 is 8. 8 is positive, so the bigger number has to be positive. So 9 goes there and 1 goes here. So my two answers is either x minus 1 equals 0, or it's x plus 9 equals 0. So x equals 1, or x equals negative 9. Well, let's see. If I plug negative 9 in, that doesn't work, but 1 does. If I plug 1 in, it works, because that's a positive length. Alright, so there we go. That's segments of secants. So we've done the segments of chords, and we've done the segments of secants. The only thing we have left, you would think is segments of tangents. But unfortunately, that's not what we have left. What we have left is segments of a secant and of a tangent. But before we do that, I want you to quickly try these three problems, just to see if you know how to do this. So take about 5-10 seconds on the video here to do it. If you set them up correctly, this is what you should have gotten. So if you can at least get the setup right, we're halfway there. Now it's just the algebra part. So if you can do the geometry part of setting it up, now it's all it is making sure that we can do the algebra. If you got stuck here, by the way, this is 1, this is 2, and this is 3. If you got stuck here, rewatch the video on just the setup part. How did I set it up? Alright, now let's see if you found x correctly. Well, I did get two answers for the last one. You should have got x equals 3 to be the solution. I showed a little bit work, so if you want to see what I did, you can see it here. I didn't show every single step, but I showed some big steps. Okay? But this is how you do it. If you got them right, good job, you're good to go. If you got the setup right, you at least have that part, and now it's just making sure you're doing the algebra right. Alright, at this point we have one last thing to go over in this section. That's the segments of a secant and a tangent. So if I have a secant segment and a tangent segment, like in this picture here in the bottom right, the tangent segment is z, the secant segment is x and y. So if I have that picture right there, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. What's that saying is if I take the external part here, y, and I multiply it by the full length, y plus x. That's the left side here. If I multiply y by y plus x, the outside part by the full length, it will equal z squared, the tangent squared. That's the setup. If you can do that, you're well on the way, and then it's just algebra. So make sure you know how to set it up. External part of the segment times the full length of the segment equals the tangent segment squared. So let's try a few examples. In example 4, I say find the value of x again. We're just worrying about being able to set it up and do the algebra here. We're not worried about word problems and trying to draw it. We're just trying to get the answer right. Alright, so let's look at this one. So the rule says, if I start with the secant segment, I take the outside part of the secant segment and I multiply by the full length. Well, it's not just 4, it's not just x, it's 4 plus x. That's the full length. And that will equal the tangent segment 5 squared. So 5 squared. Solve for x. That's the setup. And at this point, it's just algebra. So external part there. Full length 4 plus x there. Tangent segment there. Square. Distribute now. 16 plus 4x equals 25. Subtract 16 from both sides. 4x equals 9. So x is 2.25 or 2 1/4. Try setting up this one on your own. If you did it correctly, you took the external part, 6, and you multiplied it by the external plus the chord itself, 6 plus x. So the full length is 6 plus x. You set it equal to the tangent segment squared, so 8 squared. External times full, 6 plus x, equals tangent segment squared, 8 squared. Distribute and solve. I get 36 plus 6x equals 64. Subtract 36 from both sides. 6x equals 28. Yep. So x is 4. Alright, I'm fine with leaving this answer in one of two ways. You either leave it as 14/3, or you could do something like x equals 4.6 repeating. Either answer I'd accept. And there we go. That's it. Set up, solve, algebra, circle your answer. Those are the 3 ways we do this. Now, here's a few more examples. I want you to quickly try all of these on your own. And again, I'm going to write down the setup, and then I'm going to write down the answer. So take about 5-10 seconds in the video, so that means pause it, and then do it to do these problems. Alright, that's the setup. If you got the setup right, you're well on the way to getting it right. Now all we have to do is the algebra, which arguably is tough. But let's do it. Alright, and these are all your answers. If you did it correctly, you should have got 2, 4.8, and 8. Now real quickly, this one had 2 answers, x equals plus or minus 2. But the length can't be negative, so I threw out the negative answer, x equals 2. Over here I got 2 solutions, x equals 8 and x equals negative 18. But when I plug negative 18 in for x, it doesn't make sense. So my only answer here was x equals 8, even though there were other answers. At this point, we have done everything for this section. So you should be able to set it up and solve. There's 3 different setups here, and it's really just your ability to memorize them and setting it up. And after that, you're just practicing your algebra from algebra. I've given you multiple examples. If you still have questions on algebra, please see me. Otherwise, till next time.